I'm here to explain why the complex plane and the empty set are both open and closed. Each of them are. So let's talk about open first. I encourage you to look at the definitions. I'll verbally say them, not write them down. C is open because if I look at the complex plane and I pick any point, Z, it's open if every point is an interior point. So I just need to check that Z is an interior point for every single Z. An interior point means that I can just draw some circle around it, some open circle that's completely where the disk is completely contained in the complex plane. Well, good luck finding a point and drawing a circle around it that's not contained in the complex plane. Since basically our whole universe is the complex numbers, any sort of open disk we draw is going to have to be in the complex plane, so it's open for that reason. The empty set is open because all of its points are also interior points. Why are all of its points interior points? It doesn't have any. Yeah, just go ahead. Try to find me a point of the empty set that is not an interior point. You can't do it. There are no points. So this is really kind of a logic trick. It's open because of just logic. The statement is vacuously true for the empty set. So closed. Right? A set is closed if it contains all of its boundary points. Well, the question is, does C contain all of its boundary points? Well, recall a boundary point is one where every open disk contains points that are both in the set and outside of the set. So if this were a boundary point, if I drew some sort of open disk, it would have to contain both points that are in C, which it clearly does, and points that are not in C, which it clearly does not. So C has no boundary points because the only points we're considering are points in C, and every point, if you draw an open disk around it, only contains points in C. So there are no boundary points. So C contains all of its boundary points because it's not missing any. This is again a little bit of a logic trick. So in summary, there are no boundary points for C. A set is closed if it contains all of its boundary points. Another way of saying that is a set is closed if it's not missing any of its boundary points. There are no boundary points for C to miss, so therefore it contains all of its boundary points, so C is closed. Okay, the empty set, same thing. We need to find the boundary points of the empty set. So a boundary set, you have a point that's a boundary of the set if every open disk around it contains both points that are in this set and points that are outside the set. Well, there are no points in here, so it's impossible to contain points that are in the empty set. So there can be no boundary points. By the same logic as over here, this has to be closed because it contains all its boundary points. Why? Because it's not missing any of its boundary points, because no boundary points exist for this. So these three, right, empty set, everything about the empty set is basically a logic trick. C being closed is kind of a logic trick, but C being open kind of makes sense, right? Just take any point you want, draw an open disk, and you just say, are there any points in here not in C? No. So therefore, it's an interior point. So therefore, every point in C is an interior point, so it's open. Thank you.